All right. So all of this is supposed to be review. If it's not, you have a lot to catch up on in the next 48 hours because on Friday we're having a quiz on this stuff. The learning targets include finding probability, finding odds, finding probability of both independent and dependent events. In other words, like with replacement and without replacement, that kind of thing. It says I can list a sample space, which would be like, if I said I'm going to roll a die, the sample space would be the numbers 1, 2, 3, 4, 5, 6. Okay? It's not real complicated. But I don't think I put the sample space question on the quiz anyway. I can calculate number of possible ways an event can occur using either combinations or permutations, whichever one is appropriate. And then I could calculate the probability of an event using those. All right. Please notice there is no review sheet for this week's quiz. The quiz will have a section on parametrics and a section on probability review. It will also have a section called 7.4b, which is the eccentricity completing the square section. That's just like the last quiz. You can also, it will have 7.4a, which is like called advanced equation writing for conics or something. And again, it will look just like 7.4a on last Friday's quiz. And that's optional. If you already have a grade you're happy with there, you don't have to do that section. Okay? It's a short quiz, so Friday before we start the quiz, I will go over questions, okay? And I can probably squeeze in some questions tomorrow, but there's no review sheet. All right, today's stuff. Are we ready? Of course, I don't have my tablet up and going, so I don't know how this is going to go. So basic probability is number of favorable outcomes over number of possible outcomes. There is a difference between a theoretical and experimental. Okay, generally, you know, if I say, what's the probability of this happening, it's a theoretical probability. You're just saying, in theory, when you flip a coin, it's 1 out of 2, right? That it's going to be heads or tails or whatever. So if we were talking a coin, the probability of heads would be 1/2. Okay, this is just in theory what should happen if all is fair. Experimental probability means an experiment has been done. You have to be given data. Okay, so there was a spinner. It apparently had an X, Y, and a Z. And they don't show us an example of the spinner, but the experimental probability of spinning a Z appears to be 13 out of 20. Is that right, guys? Did I total that? Okay. Any questions about that? It looks to me like the spinner didn't have X, Y, and Z the same probability of happening, right? Maybe X and Y were smaller slices of the spinner and Z was a big chunk. We don't know that. You can have an experimental probability of anything, right? You can talk about the probability that Jordan's going to shoot the next, okay, somebody in your time is going to make the next free throw they shoot, right? And that's based on past experience. Okay. All right. Probability of choosing a girl in our class. How many girls do we have? 9? 10? 10? Got 11? All right. Well, let's go with 11 out of 20 just to be done, okay? So our probability would be 11 out of 20. That's actually a theoretical probability, right? Because we didn't do an experiment. We just said out of the total possible, okay? And I don't know that I've counted right. It doesn't really matter at this point. Yes, we do. All right, deck of cards. I put some pictures on here. How many of you are really feel totally unfamiliar with a deck of cards? Anybody? Okay. 52 cards. We're not talking jokers here. Okay. 4 different suits, aces through 10, and then jack, queen, king. I would never ask like how many 2-eyed jacks or anything crazy because, well, different sets of cards have like the jack is facing sideways on some suits and not the others. Yeah. I would never ask anything like that. Okay. But in general, a regular deck of 52 cards. How many are red? Half of them. Probability of choosing a heart. Yeah, there are 13 out of 52, just in case, but it is a fourth. Probability of picking a red 7. Okay, there are 2 red 7s, hearts and diamonds, out of 52, which is 126. Are we good? A black heart. Only if you're talking about Hofbauer, right? Yeah, okay. When you roll a regular die, okay, I think, well, I have a set of dice that has everything from, I think, 4. Does it have, I don't know, to up to like a 20-sided die. So they can make them out of different polyhedrons, but unless I tell you otherwise, it's a 6-sided die numbered 1 through 6, okay? So the sample space, what did I just do? What am I missing? Woo! That was a moment. I don't know what happened there. Okay. So the probability of a 4 is 1 out of 6. Of an even number, 1/2. A greater than 1. And a 7. Okay. Whew. We survived that. Yeah, I was going to say there are dice. All right. Bill, John, Sue, and Ann are up for promotion. Their boss is going to pick a team of 2 people to lead their department. Everyone's equally likely to get the position. Show the possible combinations for the team. Okay. This is just because it's almost spring break and it's so amusing, but we'll list them by first letter. So we could have this. We could have this. We could have this. Are we having fun yet? Okay. Or what? John could be with Sue. John could be with Ann. Or Sue and Ann. That's it, right? 3 of them have A. 3 of them have a B. 3 of them have a J. Right? So it's all good. So what's the chance that Bill and Sue get the promotion? 1 out of those 6 have both Bill and Sue. The team is made up of 2 men. The 2 men would be only if it was Bill and John, right? Everybody, all the other combinations have either Ann or Sue. Ann is one of the people. 3 out of 6 or 1/2. We good? All right. Don't write out the sample space because it's just horrible. It says a couple's planning of having 4 children. Write out the possible combinations. Remember, birth order would constitute a different outcome. This is one you could do like a tree diagram for. They had a boy or a girl. Second, they could have another boy or a girl. Or if they had a girl, they could have a boy or a girl. But if they have 4 children, this is getting really wide, really fast, right? It's not going to go well for me. I actually, this is off the internet, okay? This is a tree diagram where the red is boys and the blue is girls, just to mess with my head, okay? Anyway, if we were to write them all out, what is the probability of all girls? Well, there's how many total? Each time there's 2 possible outcomes, right? And we're talking 4 kids, so that's 16 possibilities. All girls would only be 1 out of 16, all boys would be 1 out of 16. Now, can you, without writing them all out, easily come up with at least one boy? Why 15/16? Does everybody get that? If all girls is only 1 out of the 16, the other 15 have to have at least one boy. Is there more questions about that, or is that it? All right. What? Not where you have to list them. I didn't put any where you have to list, okay? I didn't put any. I don't want to grade them. All right. So probability rules, guys. Probability of event is written P of A, kind of like function notation, okay? Probability of A. The probability of event is always between 0 and 1. The closer to 1, the more likely the event is. The sum of the probabilities for an independent event has to total 1. In other words, the probability I get a 1 or a 2 or 3 or a 4 or a 5 or a 6, if those are each 1/6, for the 6 different outcomes, they total 1. You get what I'm saying? So if I had this as my spinner, A, B, and C, the probability of getting A is 1/4, B is 1/4, and C is 1/2. So those all total 1 because 100%. Does that make sense? Okay. The probability of an event not occurring is 1 minus the event occurring. So if I told you there's a 3 out of 5 chance that you get paid $100 when you leave, the chance you don't is 2 out of 5, right? 1 minus that, okay? It's also called the complement. So if the probability of an event occurring is 3, what's the probability it doesn't occur? We just did this question. 2 out of 5, right? Okay. I don't think there's odds on this. Okay, before I turn the page, at the bottom here, let's just talk about odds for 1 second, because it's all over the worksheet number 3. The definition of odds is favorable outcomes to unfavorable outcomes. And I write it with a colon. You can write it as a fraction. It's perfectly fine. I write it with a colon because it helps my brain keep straight. Am I talking about probability or am I talking about odds? Because otherwise my brain gets all confuzzled. Okay. So on the event we just talked about, the probability of the event occurring was 3 out of 5. Okay. What are the odds that the event occurs? 3 to 2. Okay, if we're talking about this one, because this is will occur out of total, right? So if you want the odds that it will occur, it's will occur to won't occur. Okay? What if I said, what are the odds the event does not occur? Okay? I can't read that, but maybe you can. There's a question like that on the quiz. It says, like, if the probability this event occurs is 7 out of 12, what are the odds that the event does not occur? And you should be able to logic your way through it. Does that, okay? I would just write, okay, 7 will, 12 total. That means 5 won't. So the probability that it won't, or the odds that it won't occur would be won't to will. All right. Just think of it like winners and losers, okay? And there's more practice on worksheet 3. All right, 1B. Independent events are multiple events that you want the probability of, but they don't affect each other. You go over here and roll a die and you toss a coin, right? Don't affect each other. What color shirt you pull out, what color pants you pull out, 2 different things, not affecting each other. All right? So what's the chance if you roll a die and flip a coin, you probably get a 5 and a tail? You just multiply the probabilities, right? That's what it says here. So a 5 on a roll would be 1 out of 6. Flip a tail would be 1 out of 2. So we're talking 1 out of 12. Anybody lost? Okay, you roll a pair of dice. What's the probability you roll a pair of 3s? Each die has a chance of landing at a 3 as 1 out of 6, right? So it's just 1 out of 36. Excuse me. If the question says something different, like what is the sum? The sum of the dice is 6. That's a different question, right? It's still not dependent. Whether what one dice lands on doesn't affect the other, but you'd have a bigger sample space because you'd have 36 ways they could land, 6 for each dice, okay? And you'd have to add up the total number of ways you could get. Let's do, what did I say? Sum is 6, okay? If I say the sum is 6, you could get a 1 and a 5 or a 5 and a 1. You could get what else? 2 and a 4, 4 and a 2, or a 3 and a 3. Okay, if you want a sum of 6, so that's what? How many different possibilities? That's 5. Yep, I can add 5 different ways that it could happen that out of 36 ways that 2 dice can land. Because there's 6 ways this one can land and 6 ways this one can land. So that's a product of 36 different ways. We could list the sample space. I probably have it on a slide somewhere, but all right. This is confusing. It says the chance of you passing test A is 40%. Chance you pass test B is 20%. Note that they are independent of each other. All right. So what's the probability that you fail test A? Everybody good with that? Okay, fail test B. Okay, if these are independent and don't affect each other at all, we can find these just by multiplying the probabilities. So what's the probability you fail A and fail B? 0.60 times 0.80, that was our fail, so that's 0.48, I think. Okay, or 48%. I'm just going to leave it decimal, lazy. Okay, pass A, fail B. Is 0.32. Okay, fail A but pass B. Fail A, pass B. Pass A, pass B. .08, right? Yes, okay. What do all those add up to? They all add up to 1. Why is that? Because I did all the possibilities, right? We're good? We're reinforcing that idea? Okay. Obviously, if there was 3 tests involved, writing out the sample space would be much bigger, but all right. Dependent events are events that affect each other. It's basically the idea of without replacement, right? What's the chance I draw a pair of socks out if none of my socks are paired together? What's the chance that I draw 2 that are the same color? Okay, because once I've taken the first one out, there's less socks in the drawer. That's what we're talking about here. All right. If you have a deck of cards, what's the probability you pull out 2 aces in a row? Well, first time, there's how many in the deck? Out of 52, okay? But the second time you go back to draw one, if you didn't put it back, then there's 3 left out of 51. Now, I realize you didn't necessarily draw one on the first time, but that's what we're trying to get is the probability that you did draw one the first time, okay? So this is how it works. That always confuses students. All right, if you multiply these together, this does reduce, let's see, that would be 113 times 1/17, which is 1 over... Thank you. Everybody knows how to multiply fractions and reduce on the calculator, right? So I can get reduced answers out of everybody. Okay. So the definition up here said, for this to be true, it's the probability of A times the probability of B given that A has occurred or the other way around. So it doesn't matter what order because you're multiplying. Okay. So you have 30 students in your class, 17 are boys, 13 are girls. You need to select a president and a vice president. What's the probability of having female president, female vice president? So we go to pick a president. We're picking what? We want a woman, girl. We have how many to pick from? The probability is 13 out of 30. But when we go back to elect a vice president, we now have 12 girls left to pick from out of 29 students in the class. I don't think I can do that in my head. Someone help me reduce that. 26 out of 1. Thank you. All right. This is where it gets a little hairier. Okay. This is talking about if you say probability of A or B. Okay. There's a fancy way of doing this. You can say it's the probability of A plus the probability of B minus the probability that both things happen. That just confuses the heck out of me. Okay. What they're talking about is if you had a Venn diagram and you were talking about this, okay? What's the probability that it was somebody in blue or green? Okay? If it said blue or green, in theory, you would say, I'm going to add up the blue, I'm going to add up the green, and then I'm going to subtract this little black area because those I've counted twice, right? I don't ever do that because I just count up how many weren't in, how many in this outside circle, this one here, and then this one, I just count them once and I'm good. But that's the theory. Okay, so from a deck of cards, what is the probability of pulling a red card or a 2? So what they're saying is you could add up all of the probability of all the red cards, okay, plus the probability of all the 2s, and then minus the probability of the red 2s. I prefer to just go through and think how many total winners there are. Does that work for you? So, probability of getting a red or a 2. Well, how many red cards are there? 26 plus how many 2s that we haven't already counted? 2. Yes, because what is the probability of pulling a red card or a 2? It doesn't say multiple pulls. We're just one trial. Better? No? Confused? What they would say is you could say a red is this plus a 2 minus the fact that there were 2 that were red and a 2. Okay? That just confuses me. I don't want to even go there. Okay, rolling a dice, what's the probability of rolling a 6 or a 3? 2 out of 6. Don't overthink it. Okay. Rolling a dice, what's the probability of rolling a 6 or an even number? 3 out of 6 or 1/2, right? Because in that case, a 6 is an even number, so it didn't change anything. Don't overthink it. You got this. In a math class, there are 14 seniors and 8 juniors. 5 of the seniors are male and 4 of the juniors are female. What is the probability you choose a senior male, a junior or female senior? Okay, let's make a chart. Or we could do a Venn diagram. But so we have seniors and we have juniors, right? And we have males and we have females. Okay, that's enough. Yep. Okay, what do we know? 5 seniors who are males. Seniors, male, 5. Okay, how many seniors are there altogether? 14 seniors altogether. So can we pick this, fill this in? 14 seniors total. Oh, my chart just got really bad. Okay, so 14 minus 5 is 9 here. Okay, 4 of the juniors are female. 4 junior females. So that's a total of 13 females. But it said there were 8 juniors total, right? They gave us that. So this one is how many male juniors? 4. So a total of 9 males, right? And a total of how many people altogether then? Because this is seniors and juniors add up to 22, and male and female adds up to 22. Are we good? Okay. So what is the chance that we draw a senior or a male? Okay, this is an or, so we could do the whole all the seniors, all the males, and then subtract the overlap. Or we can just figure out who's a winner, right? It says senior or male, so all the males and all the seniors count, right? Everybody good? What is that? 18 out of 22 or 9 out of 11? Okay, probability junior or female. So you're a winner as long as you're junior or a female. Some of you are thinking I could just subtract, right? Because the only non-winners are these senior males. But whichever is easier for you to understand. Okay, juniors, both of those count, and this additional set of senior females count. So that's 4 plus 4 plus 9. That doesn't reduce, right? Okay, junior or senior? Yeah, everybody's a junior or senior in our little chart, right? So 22 out of 22. Okay, the other thing they will ask, and I'm going to practice this while we're here, they will ask a question like, probability it's male given it's a junior. What does that mean? That's called conditional probability. That means you have to have a junior. So you're now only talking about this group, okay? So male given a junior is 4 out of 8 or 1/2. Male given a senior would be 5 out of 14, okay? Or it could ask, what would it be if it said probability of probability of junior given male. So given males, now you're only talking 9, right? Junior given a male would be 4 out of 9. Everybody good? We'll practice that. It's on the worksheets. Okay. Your doctor's going over statistics of a risky operation. Oh, this question just kind of hurts. Surgery has a 25% failure rate. If the surgery works, there's still a 17% chance of infection. The surgery can fail and you can still get an infection 3% of the time. What are your chances of a successful infection-free surgery? Okay, what's the chance of a successful 75, right? Infection-free. Okay. So we have the surgery and we have it succeeds or it fails. If it succeeds, there's still a chance of infection, right? If it fails, you could still get an infection. So success and no infection. So if it works, there's a 17% chance of infection. Yeah, so 83, no infection. So what are we going to do with those? Yep. 62.25%, if I write it as percent. Did someone get that? Okay. If we wanted to double check that, we could find all four possibilities that we've listed, right? And make sure that it adds up to 100%. It's right, so we're not going to do that, but okay. That question's not on the quiz. Okay. At a clothing store, statistics show that if you buy pants without trying them on, you have a 30% chance of them being too tight, 10% chance being too loose. What is the probability you purchasing pants that actually fit if you don't try them on? So assuming that those are the only choices, right? Too tight or too loose, or they fit. So that would leave 100 minus 30 and 10 would leave 60%. It's a poorly worded question, in my opinion. Not the wording so much as the concept. A lot of other things that could be wrong. They too short, says someone tall. Okay. To meet state standards, Harlem does research and discovers 80% of students need help with math, 70% need help with English, and 55% need help with both math and English. Okay. I find this one kind of easier to do like this. What percent need help with both? We have math, English, 55. Okay, 55% need help with both. 80% need help with math. That could be math and English or just math. Well, if there's already 55% that's both, what does that leave? 80 minus 55, 80 minus 55 is 25. Yes, okay. Just English. If 70 total need help with English, and we already have 55 in the both category, that leaves 15. Okay, so my diagram is not proportional, right? There's actually very much overlap. Okay, what is the probability that someone needs help with math or English? Or means both, guys. Can be math, English, or both. Okay. I know that's a struggle for some of you. Okay. So it's 25 plus 55 plus 15, which is what? 95%. Yes. Need help with only math or only English. Okay. If it said and, then you'd want just the 55% in the middle. Yeah. Okay. But you have to think of it as like, if I said, how many people are wearing red or blue? If I ask, are you wearing red or blue? Well, if you're wearing both, you're still wearing red or blue, right? Okay. Conditional probability, this is what we were just doing a minute ago with the seniors, males, all that good stuff. Okay. So if we're picking, we have this chart. What is the probability that we pick an independent? 17, this is total, right? And this is total. So there are 17 independents out of 140. The probability of the denominator is still everybody. When it says given, that's when the probability, the denominator changes, okay? Probability we pick a production worker. 63 Democrats, 21 Republicans, 8 independents for a total of 92 out of 140. 23 over 35. Thank you. Independent or production worker. So all the independents count and all the production workers no matter what, right? So that's the way I do it. I just add them all up. 17, 38, 101. Anybody helping me? Yeah, it's 101, right? because it's only 39 that don't count out of 140. I don't think that's going to reduce, is it? Okay. This is not the same, though. Executive, given they're a Republican. Now, given they're a Republican, we're only picking out of 55, right? An executive is 34 out of 55, which I don't think reduces. Independent, given a production worker. So given a production worker means we're only dividing by 92, yes? Total production workers. Since I've made a mess of this. Okay, so now we're talking about out of these 92, how many are independent? 8, which reduces to... Thank you. Those seem okay? There's more practice, but in the charts. Okay. This isn't on the quiz. Do we have to do this? Okay. So you could do like, I'm going to flip a coin. It could be heads or tails. And then I could get 1, 2, 3, 4, 5, 6 on the coin, right? 1, 2, 3, 4, 5, 6. Yeah, something like that. It's just disgusting. I'm not going to. Okay. In a class of 30 students, we've chosen a president, a vice president, and a secretary. A student can hold only one position. How many different outcomes are possible? How many ways can we pick a president? Okay. How many people remain to choose for a vice president? How many people remain to choose for a secretary? So how many different ways can this happen? What? There is. We're going to talk exclamation mark no. Okay. It is where it counts down, but it counts down all the way to 1. Okay. This would be, I would do it this way, but it is a permutation, like you're picking 3. So it would be what we're going to talk about here in a second. It would be 30p3. Yeah, I prefer to do this because this makes sense to me. Okay, revisit the 4 children problem, create a tree diagram. Oh, no, we ain't doing a tree diagram. How many possibilities were there? 16. Okay, we're going with that. Basically, it's just reminding you, okay, there's 2 chances each time. All right, the question on the quiz is like, you go to Subway, there's 8 kinds of bread, 5 kinds of meat, and 12 kinds of cheeses. How many different sandwiches can you make if it has to have 1 bread, 1 cheese, 1 sandwich? You just multiply them together, right? That's the counting principle. Okay. Okay. Permutations. Permutations. When n is the number of things you're choosing from, and r is the number of them you are choosing, and order matters, okay? You can't have repetitions, then it's a permutation. And this is the formula, which I am never going to make you use. Oh, factorial is on the outside. That factorial means you're counting down. Like 8 factorial is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. You should have all had some of this last year, okay? What it means when it said order matters, okay? We'll talk about where to find this on the calculator in a minute. But what it means when it says order matters. It means you're counting Johnny times Sue, and you're counting Sue times Johnny as 2 separate things. They're counting twice. Do you understand what I'm saying? Okay? Counts twice. If I'm getting a president and a vice president, I want that to count twice, right? Because I want Johnny, Susie, Susie, Johnny, one president, one vice president to count twice. Order matters. If I'm handing out $100 bills at the door and I have two of them, Johnny and Susie don't care who came first, right? That doesn't count as two separate possibilities. If Johnny and Susie each get one, that counts only once. The group of two counts once. That's a combination. And then there's a bigger divisor. Okay. You're choosing from n things, and order doesn't matter, so you don't want to count them separately. You only want to count that happening as one event. Okay. I can't spell separate. E-R-A-T-E? A-R-A-T-E? Doesn't count things as separate events. All right, on your calculator, this is NPR and this one is NCR. Let's take a minute. Nope, that's not where we're going. To open our calculator. Why can't I find my calculator? Where's my little... Oh, he is right there. There you little bunny. Okay. Why do I still have all this open? Just kidding. All right. On the calculator, it is under the math button. It's faster to arrow to the left, or you can arrow all the way to the right to the probability menu. And it's here, choice 2 or choice 3. Okay, NPR, NCR. Now, you do have to put numbers on the older version, like I have running right now. You'd have to put in like 30 and then go to the button and then put in the other one. I think on the newer version, you just hit it and it brings up little boxes, right? I don't know if I can turn that on here. I thought I could, but if I go here and I do this, just kidding, math, arrow left, choose this. Then I get to maybe I'm wrong. Maybe this calculator won't do it that way. Okay, doesn't like me. You can just type in little boxes, right? It gives you the little boxes so that it looks like this. And you can type in there. Okay. Well, that example would go up here. But all right, so our example is 32 people in your class. You're choosing a team of 3 people. Do you want ABC, CBA, and BCA to count differently? Is that 3 different teams? No, so order doesn't matter. Okay, if you don't want them to count differently, order doesn't matter. So then it's going to be 32C3. 32, math, left, choice 3, 3, 4960. Someone else get that? Okay, this is the way I remember it, guys. C is combination, which is like a committee. I remember committee, combination. Order doesn't matter if you put on the committee, right? P, permutation, priority. There's some kind of order or priority. All right, we'll finish talking about that tomorrow. All the circled problems on worksheet 3 through 6 are on the quiz Friday. Just letting you know, they could be. Tomorrow, because we got through like all the notes, we'll finish up this little tiny bit tomorrow, but otherwise tomorrow's going to be a work day to work on all this stuff. Yay!